morning, folks. So today I'm going to talk a little bit about periodicity, matter as an energy kind of waveform. Bear with me. I'm not, deeply versed in quantum physics, but I'm going to dip a toe into quantum physics here because I'm reading stuff about it, so I'm trying to understand it. So bear with me. I probably will get things wrong, and that's all right. I'm just trying to get my head around it. So I was reading Science in the Modern World by Whitehead for my class, and came across a section where he starts talking about matter and the way that it looks through the lens of quantum physics. So he's talking about electron behavior, and he's talking about how when we try and observe electrons are, for those that don't know, which I assume is very few of you, I assume all of you pretty much know what I'm talking about. Electrons are little tiny particles that fly around the nucleus of the atom. Anyways, so when we try and observe an electron, we can't see it move continuously. We don't get to see it move from point A to point B. We see it at point A for a period of time, and then at point B for a period of time, but we can't find it in the middle, apparently. We, meaning people who look at these things, which is not me. But yeah, so there's basically this discontinuous, almost jumping type of motion to it. So you see it here, then you see it there, then you see it there. So it's moving, but it's almost like, skipping parts. And that's weird, right? Because at least from a philosophical and experiential standpoint, we don't experience the world that way. It's weird when stuff disappears one place and shows up in another. That's not how we experience reality typically. That's kind of shocking to us. We call it magic and all kinds of other things. We're like, that's not possible. It must have gotten from here to there somehow. It can't just disappear over there and appear over here. Things don't do that. So it's a little bit perplexing when we get down to the basic structures of what we consider to be the reality of matter and find that it behaves in ways that doesn't reflect what we expect matter to do. So Whitehead offers an explanation for this, not one he made up, but just one that has been proposed by other scientists, I believe. But he says, essentially, that matter, if we think of matter like we think of energy, relativity is Einstein's theory, equals mc squared. That says matter is energy. I don't know how this carries over to quantum physics. I'm sure some of you do. But if we think of matter as energy, we think of energy as a wave, as a waveform. Just think of sound. Sound is vibrations in the air that our ears pick up and interpret, right? Light is light waves that our eyes are taking in and are being interpreted by our brain. So we're getting these frequencies of oscillations, essentially with the sound. And if we think about it, sound is this constant alternating between sound and silence. One part of the wave, the top you hear, the bottom you don't. So it's on off, right, constantly. But really fast, like you're looking at a fan and can't see between the blades, kind of thing. It's moving that fast. Okay. I apologize for my descriptions. Could be better. But, okay, so getting back to it, if matter behaves like energy, that means what we're seeing, say, when we look at an electron, if we just say, like, okay, well, if an electron behaved in a wave pattern, we wouldn't see a continuous pattern. We'd see it on, off, on, off, on, off. And Whitehead is pointing out that that's basically what we're observing in the movement of electrons, is we're seeing it in one place, and then not there, and then in another place, and then not there, and then another place. So it's on, off, on, off. So he's basically saying that matter behaves, when you zoom in, it behaves kind of like a wave pattern, like of energy, which makes sense from E equals mc squared standpoint, I suppose. But it's really counterintuitive that matter does that, at the quantum level. It's a little disconcerting, but Whitehead gives an analogy with music, okay? So with music, if you're listening to music, you can't do it all at once. It has to happen over a period of time. So music has to unfold over a period of time in order for you to hear it. If you stop the music at a single point, you don't have music. You have either silence or some note. That's it. And that's not music, right? Music is the whole pattern and arrangement, and interplay and harmony and melody and all these different things. It's not just one note in that piece. You can't call that note music. You can call it a note, but you can't call it music. And so what Whitehead is saying is, when we want to observe an electron, it's an event, actually. It's an energetic event that takes a period of time to unfold. So when we zoom in into the quantum level, get real close and try and look at these things, what we're doing is essentially looking at music one moment at a time. So it's like one note at a time. So we have a very hard time understanding, though, the whole piece of music if we only look at one note at a time. All I see is G. That doesn't tell me I'm listening to, Beethoven's symphony. I just hear G, a note, one note. Or I hear nothing because it's in between notes or something. So what he's saying is that by trying to reduce matter down to this other reality, we may be missing out on part of its unfoldment. And another way of looking at it is that matter behaves as energy, like a waveform. And so at that level, if it behaves as a waveform at that micro level, it goes and flies in the face of our intuitions about the way matter is supposed to behave. So, okay. So I'm not going to make this very long. I'm going to wrap this up. It's about 7 minutes. Anyway, this just grabbed me because I thought it was very interesting, and I'd never heard it before. I mean, I heard about quantum foam and stuff popping in and out of reality, and whatever, Schrodinger's cat, and Heisenberg's uncertainty principle, not Heidegger, Heisenberg's. Anyway, so I'm kind of familiar with quantum weirdness, but I never really heard this, and I found this really interesting. Number one, because matter behaves in counterintuitive ways, and number two, it tells us something about the nature of matter, that it behaves in ways that are similar to energy, which I thought was fascinating. Thinking of energy, matter, thinking not just that matter can be converted to energy, like in a nuclear explosion, but something more along the lines of matter actually behaves like energy. So it's kind of interesting, because then, there's like a continuum. Maybe energy behaves like matter in certain ways too. I'm sure that's possible, and I'm sure some of you know about that, and I don't. Anyways, thanks for listening. Hope you got something out of it. I find this stuff fascinating, and I'll just keep dropping little segments as I stumble across gems. So have a great day. Bye.